Today we will go over the 4 different types of transformations. Okay, here we go. Transformation. Transformation is a change in position, shape, or size of a geometric figure. So transformation in geometry is when we move things around, that's called a transformation, or we change the shape or size. Now there are 4 different kinds of transformations we will look at. Translation, which is when we slide the shape over. Reflection, when we flip. Rotation, when we turn around. And dilation, when we change the size, resize. We make it bigger or smaller. So before we go over the 4 different kinds of transformations, here's some extra vocab we will need to know. A pre-image is the original figure before a transformation. Before we do anything to it, we call that a pre-image. Then we have just the image, which is the resulting figure after a transformation. This is after we move it around, we change the shape, change the size. That's called the image. Down here, some notation. We have triangle ABC being transformed into triangle A prime, B prime, C prime. This single quotation mark here means prime. That just means it's the new A. It's the second A. So we have the old A, the original A, we transform, it goes on top of A prime, the new A, the second A. So A goes to A prime, B transforms to B prime, and C transforms to C prime. Last vocab word, isometry. It's when triangle ABC or pre-image is congruent to triangle A prime, B prime, C prime, the image. So this is pre-image is congruent to the image. That's called isometry. Now let's go over the 4 kinds of transformations, starting with translation. Translation, let me zoom in, is a slide or shift. Sliding or shifting a figure along a straight line. For example, this triangle, I move it over here. That's a slide or a shift. In math, we look at translations on a graph. So right here we have triangle ABC and triangle A prime, B prime, C prime. Again, the prime tells me this is the second, this is the image. So I start with A going over to A prime. When you count on the graph, you count how much did we move left or right, how much did we move up, down. Here we figure out we move 4 to the right, down 9. So it is translated 4 units to the right and 9 units down. Motion rule is how we express that translation mathematically. On the x side, we move to the right. For the x, moving to the right means plus. We move 4 units, so x plus 4. On the y side, we move down. On the y, moving down means minus. Y minus 9. So this can be x plus or minus, y plus or minus, how much you move. So minus left, plus right, minus down, plus up. Next, we have the reflection when we flip things over. Mirror image of point A is reflected over the x-axis. Over here is my x-axis. And A is reflected over to A prime. We flip it over. Notice when we reflect across the x-axis, from the top part of the graph, it flips to the bottom part. The x-coordinate stays the same, while the y-coordinate changes signs from positive to negative. If we were instead to reflect over the y-axis is this line up here, So this point reflecting over the y-axis, that would mean that the y changes sign, but the y stays the same, but the x changes sign. And in a minute, I'll show you how to find those reflections by counting on a graph. Next up, we have rotation when we turn things around. Right here, let me zoom in some more. Point A is rotated 220 degrees to get A prime. It's when you turn something, turn it around this way, rotation. Or here, F is rotated 135 degrees. In the next few days, what we're going to be spending time on is looking at rotations with 0 degrees, (90-degree rotation, 180-degree rotation, and a 270-degree rotation. Is what we will focus more on in the next few days. Last up is dilation. A prime, triangle A prime, B prime, C prime is a dilation of ABC, which means dilation can mean either an enlargement, getting bigger, or a reduction, getting smaller. In this case, here's ABC, going to A prime, B prime, C prime, it became bigger. More specifically, it had a scale factor of 4. That word scale factor from the similarity unit comes back. Scale factor 4 means in context, your new triangle is 4 times bigger than the old triangle. So there you have the 4 different kinds of transformations. Now let's see this in action with some problems. Okay, so I have 4 sets of problems right here. And for each problem, it gives you your original pre-image points, and it gives you the rule, how do we transform it by, and we have to graph the new image points. So number 1, I have point 3, 5. I'll do number 1 right here. T is at 3, 5, which I already graphed, 3, 5. It tells me to translate twice using the rule x minus 4, y minus 5. As I mentioned earlier, x minus 4, x minus means going on the left. Y minus 5, y minus means going down. So this tells me to find my image, my new point, I go left, 1, 2, 3, 4. Let me do that again. 1, 2, 3, 4. And I go down 1, 2, 3, 4, 5 to find my new T prime. So the rule told me move left 4 and down 5. So that's a translation. Next, number 2 tells us to reflect across the x-axis. Here's my point I, and we reflect over across x-axis. The x-axis is this line right here. And you will be expected to know which one's the x-axis, which one's the y-axis. You should be able to figure that out on our own. When you're reflecting a reflection, we call this the line of reflection or the axis of reflection. When we reflect, I'm going from up here, flipping over to the other side. That distance from the point to the line needs to stay the same because your line of reflection is in the middle. So here's what I mean by that. Going from I straight down to the red line is 4 units. So if it's 4 units above, that means a reflection needs to go 4 units below. So from my line, from the point I, that's 1, 2, 3, 4 units. There's your line. Then you go 1, 2, 3, 4 to find your I prime. So this is a reflection over the x-axis. 4 units this way and 4 units this way. Number 3. My example number 3. It says reflect across the line y equals x. Let me write that down. Across over y equals x. So if you remember back from your algebra 1, the line y equals x is also known as a parent linear function, which is this diagonal line right here, which can be found by going from the origin up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1, and so on. From the origin, down 1, left 1, down 1, left 1, down 1, left 1, down 1, left 1, and so on. That's your line, y equals x. Because this is a diagonal line, unlike number 2, where number 2 we had a horizontal line, right here we have a diagonal line, which changes our rules a bit. What's going to happen is this. From your point B, which is at negative 2, 5, count straight down until you hit the red line. So from B, counting straight down until we hit the red line, that's 1, 2, 3, 4, 5, 6, 7 units. The diagonal line makes us change directions. So instead of keep going down, I now have to change directions and go right. 1, 2, 3, 4, 5, 6, 7, right here, B prime. So what happens here is when you take B and you fold it across the diagonal line, that's where it ends up, folding across. And again, we got that by counting. From B, straight down is 1, 2, 3, 4, 5, 6, 7. Because it's a diagonal line, we change directions and go right. 1, 2, 3, 4, 5, 6, 7. Last part, number 4. Reflect across the line x equals negative 2. X equals negative 2. When we say x equals, that means we cross the x-axis, which again, let me remind you, this is the x-axis at negative 2, 1, 2. Negative 2 is right here. That means my line goes this way. This is the line x equals negative 2. So when we're reflecting, this is similar to problem number 2, where you just count how far from the line. Because it's a vertical line, we can just count across. So right here, point Y is at 0, 4. Going from Y to the line of reflection, how far is it? It's 1, 2 units. Then it's a mirror. We keep going. 1, 2. And Y prime ends up being right there. 2 units on the right means 2 units on the left. Okay. So that's how you find your reflections and translations. Over here on the back, you'll also see some questions. Number 5 is asking, how did we get the rule? And we have an example here. Let me focus at A. A is at 3, negative 1. A prime is at 0, 3. So we look. Going from negative 3 to 0, how much did we add? We added 3. So x plus 3. On the y side, going from negative 1 to positive 3, how much did we add? We added 4. So y plus 4. And there's your rule. That's for translation. Translation, when we slide things over, we just figure out How much did we add to the x or y? Add or subtract to the x or y. Number 7, determine the line of reflection. This is best done by sketching on a graph. So let me go ahead and plot my 2 points on a graph right here. A is at -4, 2. A prime is at -4, -6. I'm sorry, -4. 1, 2, 3, 4, 1, 2. Sorry, A is supposed to be here. And A prime is -4, 1, 2, 3, 4, 5, 6, -6. A prime is right there. The line of reflection is exactly in the middle of those 2 points. So, to find the middle, we just count. From A to A prime, it's 1, 2, 3, 4, 5, 6, 7, 8 units. Halfway, middle is 4, so I count. 1, 2, 3, 4. So my line's probably going to be here. Because I go from up here, flip over to down there, I fold my paper this way, meaning if I fold my paper, my line goes this way. Okay, my line crossed the y-axis. This line going up and down is the y-axis. It crossed the y-axis at -2, 1, 2. So we say this line is y equals -2. So the key thing for finding line of reflection is that line is always in the middle of your 2 points. So 4 and 4. Alright, so there you have it. Our 4 different kinds of transformations: translation, reflection, rotation, dilation, and examples on the first 2, translation and reflection. Tomorrow we will go over rotations and then cover dilations after that.